Hello, this is Science for Cycle 3, Week 2, and today we're performing an experiment called Water Drop Lens. So again, as an overview, there will be a Bible verse at the top of your lesson plan, and then there's a little discussion prompt as well if you want to discuss that Bible verse with your students at the beginning or the end of your class to kind of weave in the Bible knowledge that we have along with the science that we're learning and demonstrate that those are really all one thing and an appreciation of God's glory in the world that God has created. And this week would be a great week if you want to spend a little bit of extra time going through the scientific method song and talking through what the scientific method looks like more methodically. The experiment won't take as long as some weeks, and so feel free to spend a little bit more time focused on those parts of the scientific method so that especially our older classes can understand them and even kind of verbalize responses when asked about them. So after you go through the scientific method, we'll get into our experiment. So last week we talked about vision, and specifically we talked about something called persistence of vision, where our brain actually holds on to images for fractions of a second so that we can string them together into one continuous image. And that's why when our vision is interrupted by blinking or something like that, we can still see one continuous image. So that had more to do with the brain interpretation of sight. But today we're going to talk about what's actually happening in our eyes when sight is taking place, when we're using our sense of vision. So the question is how a lens works to magnify objects. So we're going to be specifically talking about the lenses in our eyes. So for the research portion of your experiment today, you'll each have a ping pong ball, and you'll let the class know that our eyes are about the size of a ping pong ball so they can visualize that. There's a diagram of the human eye in your lesson plan, and so you'll talk about the different parts of the human eye, how light enters in through our pupils and travels through the lenses in our eyes and to the back of our eyes called the retina, which is where that light should focus, and then it gets transmitted through our optic nerves to our brains where it is interpreted. And again, the interpretation was what we focused on last week. This week we're going to focus on the lens itself. So there's actually another diagram in your lesson plan that shows different types of lenses and what they do with light. So it'll show that a convex lens focuses light to a certain point. A concave lens focuses light outward, so the light actually spreads outward when it goes through that lens. And it also shows just a flat plane lens, which can turn light, but it shines light in a straight line when light goes through it. So you can talk to especially the older classes about what type of lens they think is in our eyes, and they can look at the diagram of the eye as well to get a better idea of that. But our eyes are a convex lens because they focus light to one point, which again should be at the back of our retinas. For those of us with vision problems, that doesn't work out exactly the way it should, but that's the idea, is that our light focuses on the back of our retinas so that our brains can interpret the image that's being shown on the back of our retinas. So what we're going to do today is we're going to make our own lenses. And I'm going to turn this camera downward a little bit so that you can see what I'm actually doing. So each student will have one of these. It is a tiny little wire. I don't know how clearly you can see it. A tiny little wire with a loop at the end. So each student will have their own, and then we'll have just some small trays or saucers with water in them, just a shallow bowl of water. And these can be shared for a couple of students if need be. And then they'll get a piece of magazine or newspaper that they can use to try to magnify the image. And so what they're going to do is they're going to dip their wire with the loop in it into the water, and if you can see, the wire is actually picking up some of the water. You can see that there's water in there. And then they'll use that as their lens as they look at the newspaper, that piece that they are using. So they should be able to see, depending on how much water is picked up, that the newspaper is magnified. They should be creating a convex lens, so a lens that kind of bends outward on the outside. Now what's really cool is that using just our fingertips, we can take a little bit of water out of that lens, and it will change the way that we can view the image through it. So it should be less focused, less magnified as we take some of the water out of that lens. We can do the same thing and add a little bit more water using just our fingertips, being careful not to get too much in. And that should magnify it even more because we have a more convex lens when we add more water. So the idea is just that they can experiment with these, see what happens when they add more or less water to those wire loops, and then share observations with each other and with you as a class. So they're creating their own lenses to try to kind of duplicate the idea of what is happening in our eyes as we're seeing things in the world around us. So that is the experiment. And then go ahead and review kind of again what's happening in the experiment, what's happening with the lens, that the lens is actually focusing the light that travels through it, and that's why it's bringing things into better focus and magnifying them for us. When we create more of a concave lens, it's actually spreading out the light, and so the image is going to look smaller. It's not going to be magnified. Instead, it's going to look smaller when we look through that lens. So this is the same kind of technology that's used in all kinds of applications. It's used in cameras when you focus in and out. It's used in telescopes, and any kind of lens that is uses this kind of technology. So that's our experiment for today. It's pretty quick and easy. The other piece, if you have extra time after that, is that each class will have a concave and a convex lens to actually experiment with. So they're just small lenses, and you should be able to tell the difference just by feeling them. Otherwise, when you shine light through them, you can tell the difference between which is concave and convex, but I will be sure that they're labeled when you get them so that you can know which is which. I have them in this little holder just because I only have 2 hands, but you can have your students take turns trying to hold these as you kind of experiment with them. So I would invite you, if you have extra time, especially with older classes, have them make some observations, maybe even make their own hypotheses about what's going to happen when we do different things with these lenses. So you'll get a flashlight, and then I have one laser pointer right now. I'm going to try to obtain some more. Otherwise, maybe we can kind of pass it around a little bit carefully, because that shows a little bit more clearly how these lenses focus light. But I'm going to try to show you a little bit through this video. It's not very dark in here, so if you can darken your classroom even more, that's probably a good idea. But you can see that when we shine this laser pointer particularly through our lenses, we're going to get different types of focus. So you can see when we shine it through this convex lens that we're getting a nice focal point, one single point. When we shine through the concave lens, as we, our point is going to be much bigger because the laser is actually spreading out. So you can see in comparison to the normal size of the laser, when we shine it through the convex lens, it comes to a much smaller point. Through the concave lens, it's going to come through to a bigger point. So that's what's going to happen with your laser. That's the easiest way to see what's going on with those. You can also use the flashlight in your phone or a flashlight that I'll send with you to try to experiment. So you can try to shine through the lens, try different lengths, holding it through the lens, because these lenses have different focal points, so at different distances will they focus light more clearly. Now again, the laser is going to work the most clearly because it is a single stream of light, but you can see here even that the concave lens is throwing the light outwards instead of focusing it inwards compared to the convex lens. So go ahead and try using the light coming through the window, use a flashlight, shine it on different things. Sorry, I'm trying to get my camera up. Shine it on different things, whether it be your whiteboard or the blank wall, or even at different images, and see if you can get that light to focus or focus outward in different ways using those lenses. And if you didn't have time last week, I'll also make sure that these optical illusion images are in there as well, so that your class can kind of again play around with what tricks our brain can be fooled into as far as vision when we're interpreting images. And that is it for week 2. Thank you.